Okay, so I presume that all of you have gone through the R lab already, the E lab they're supposed to do for R, because you'll be doing a bit of R today. And the next subsequent two labs is actually using R. So if you have not done so, please go and do it. Otherwise, you'll be pretty confused. All right, we shall start. It's 1 o'clock already. So welcome back. So anyway, today what we are doing is on ANOVA. So the full name for ANOVA is called Analysis of Variance. So all of you should know that by now. And what we'll be doing mainly is on one-way ANOVA. I will show you a little bit of how to do two-way ANOVA, but that's not in your syllabus. Repeated measure, we kind of put it out as well. So based on the lecture itself, we don't have to do a lot of it. Okay, because repeated measures ANOVA is, if you have multiple, it's almost like a PET t-test as for ANOVA version. Okay. So when do you use ANOVA? Usually is when you have two or more samples. Okay, you use ANOVA when you have two or more samples. So let's look at that. There are extensions for it. Okay, your ANCOVA, MANOVA, and so on, and MANOVA. Okay, so there are actually a lot of differences, a lot of extension for ANOVA. So ANOVA is actually very versatile. Now you have ANOVA in your data analysis tab. So let's open up your diabetes, the diabetes data set. And inside your data analysis tab, the first two, one is on single factor ANOVA. That single factor ANOVA, that's one-way ANOVA. Okay. Two-way ANOVA is two-factor ANOVA with and without replication. So that's actually up to here. Anything more than that, if you need three-way ANOVA or more, then you have to use R. All right. So let me show you how to actually do ANOVA. Now let's say task 1, I leave it to you to verify, because in your lecture notes in question 2 and up to question 5. So you should be able to use Excel to do your ANOVA test. Okay. So what we are going to do today is on your data analysis, on your diabetes. And the first one is to compare total cholesterol against the frame factor. So far, any problem?
No.
No. Okay, so how many frames? Look at the frames. If I do a filter, I find that there's actually 3 frames, small, medium, large. So my hypothesis is really this. Okay. Is the cholesterol level, the total cholesterol level, that means column B, for the average cholesterol for small frame, is it equals to medium frame? Is it equals to large frame? Okay. And for ANOVA, the alternate hypothesis is at least one of them is not the same. So in order to do that, what we need to do is to pull out the data. Okay. So let's pull out, highlight column B and column L, press Ctrl C, copy, and go to another tab and paste it there. Okay, so we call this as your task 2. Okay, try to do this for yourself first. Make sure that you have 399 rows. Okay, do that first. Okay, so far, once you're okay, then raise up your hands. Otherwise, I do not know. Yep. Okay. All right. Then put down the next step. What you do is you highlight column A and B. You sort. You sort based on the frame. Make sure that you click on this. My data has headers. Sort based on the frame. So it will actually based on alphabetical order, large frame first, then medium frame, then small frame. Okay. Okay, look at me first. What you need to do is you have a large, medium, and small. So what you need to do is go and find all the large frame. Okay, so a large frame is up to here, 105. Highlight all the cholesterol for large frame, copy, or you can cut if you want to. Cut is safer because then you can check whether do you have anything. Then paste on the large frame. Okay. Medium, you do the same. Make sure you don't overshoot. Okay, so you get all the medium frame, cut, and you paste into the medium column. So as you expect, small frame, cut and put inside the small frame. Okay, so do that first. Once you are done, raise up hands. Okay, so now we can write the null hypothesis. The null hypothesis is the average cholesterol level is the same regardless of frame. Okay, that means basically all the frames are same. Alternate hypothesis is that at least one of the average cholesterol level is different. It's different from the rest. Okay. All right. So the rest. How about Lucas, Jingru, Jolene, Saki, and Zul? Okay. Jolene, Zul. Or Zul, I'm not sure. Can you raise your hand? If you can't, then use a conversation. Okay. Then put down your hands. Okay. You see all your hands there? Good. Okay. So how do we do the ANOVA? Basically, you go to your data analysis tab. I'll show you data analysis. You go to one factor because we have only one factor. It's body frames. So go to one single factor. Now the input range, you can highlight all the three columns. Group by. It's actually grouped by columns. Okay, because you want by columns. So label in the first row. That's what you always do. Output range, you just find an empty spot. Okay, then you click OK. And that gives you your ANOVA table. Okay, try it out for yourself. If you can get that, then again, raise our hands. Okay. Make sure that your degrees of freedom, your total degrees of freedom is the same as mine. If the total degrees of freedom is wrong, that means your grouping is wrong as well. Okay. Okay. So how do you read this value? This is your F statistic. The F means F statistic, and this is a p-value. So based on this p-value, do we accept or reject null hypothesis? Let's try Lucas. Do we accept or reject null hypothesis? Lucas,
Hello.
do we accept or reject null hypothesis based on this p-value?
Alpha bigger than p-value. Wait, I don't remember.
Alpha greater than p-value, then you accept null hypothesis. If not, you reject null hypothesis. So you accept or reject.
Alpha bigger than accept. Wait. Oh. I'm very confused.
So p-value is 0.009. Do you accept or
Yeah,
reject
yeah.
null hypothesis?
Not too sure. Wait.
Okay, then this is the F critical value. F critical value is 3.018. Your F statistic is 4.75. Based on the tutorial, do you accept or reject null hypothesis?
Accept.
Why accept? Your F statistic is more than critical. You reject null hypothesis.
Yeah, right. Okay. I remember now.
If the
Okay.
p-value, again, if the
Right.
p-value is below 0.05, you reject null hypothesis. Okay, so you reject hypothesis means that at least one of the frame is different. You accept the null alternate hypothesis. What ANOVA does not tell you is which one is different. Okay, maybe all three are different from each other. It could be because you look at the average. The average cholesterol level for large body frame is about 208. For medium body frame is 21, nearly 214, and small body frame is 197. So it could be totally off. Okay, so this is how you use your ANOVA. So far, any problem?
Hi, Chair. I'd like to confirm, right?
Uh-huh. Are you
I thought,
first?
hi, I'm Jordan.
Yes.
Right. I thought p-value is, if p-value is larger than your alpha, you fail to reject your null hypothesis.
P-value is larger than alpha. You fail to reject your null hypothesis, correct?
Okay, thank you.
Yeah.
Okay,
Now,
thank you.
is this p-value larger or smaller than alpha?
Oh, right. This is smaller. Yeah, sorry.
Okay.
Sorry, I see wrongly. Yeah, my bad.
All right. So I have a question for you. Since we always say that your t-test is for 2 samples, okay, your ANOVA is for more than 2 samples. Now, question for you is, can I use ANOVA for 2 samples? Can I use ANOVA for 2 samples? So, Shuyun, why not you just make a guess? Yes or no?
I think yes.
Yes, right? Okay. But can you use, if I have 2 samples, I plug it into my ANOVA equation, it will still work. It will not give me error, correct? Okay. So we can actually use ANOVA for 2 samples. Now, however, your t-test, your 2 samples t-test, right? You have, remember, equal variance and unequal variance. if I use ANOVA for 2 samples, what does it really mean? Remember when we do t-test, we actually have to do your f-test to check whether is the variance equal first. But we never do that for ANOVA? Which means that if I do ANOVA for 2 samples, it will actually be the same as your t-test assuming equal variance. Do you think so? Damien, do you think that is the case? Or is it going to be ANOVA is actually unequal, t-test for unequal sample, unequal variance? So Damien, what do you think?
Is it unequal?
Is it unequal? I don't know, you tell me.
I think it's unequal.
You think it's unequal. Okay, so let's see. Okay, the answer is actually equal. Okay, the answer is equal. So let's see. That means I'm trying to tell you to do, or at least show you, is if I do a t-test and I do a ANOVA for 2 samples, what is going to happen? So let me just reduce all this. Okay, height. Okay, so I'm just going to look at small, large, and medium frame. So let me do a t-test. T-test first. Now t-test, I assume equal variance. Okay, because I say that it is equal, right? So let us do this. Okay. Range 1 and range 2. Okay, so I have this. Then let me do the ANOVA version and see what happens. Okay, ANOVA, now I have here, also small, large, and medium. The output range now I have to change. Maybe I change to here. Okay, so let's look at these results. Okay, you see that the mean and the average is the same, right? So this is no problem. The variance also is the same. Variance here, no problem. Okay, observation is the same. So summary statistics, no problem. Now, what I want you to look at is this number. This yellow number, what can you say about it? If it's two-tailed test, look at the p-value. The p-value is also identical. Okay, but let's look at the 2 yellow columns. What is the relationship for your p statistic? How do you complete this equation? How do you complete this equation? What is the relationship between t statistic and f statistic? That actually it gives you the same p-value. Anybody want to try? Trevor, any suggestions?
I'm not sure.
Think. Look at the 2 numbers. The 2 yellow cells. The p-value is identical. Okay. What happens if you take your t-statistic, use a calculator, take a t-statistic, and you square it? That means you square this, but does it equals to this number? Trevor, why not you try it? Trevor.
Yeah.
Okay. You take this, you square it. You get this value. Okay, this is why when you use your ANOVA for 2 samples, it is actually equivalent to your t-test with equal variance, because there is no way ANOVA can handle unequal variance. Okay, so that is the reason. Okay. It also means that there will be some people that use ANOVA all the time, and we already tell you that Z-test, your normal test, your Z-test, is more or less a hypothetical test. We seldom use it. T-test, it appears that we also don't use it unless you're testing for unequal variance. Okay. So exactly this is how you do ANOVA, one-way ANOVA. It's nothing very difficult. So we have done here already. This is the answer, 0.0904. Okay. Post hoc tests will actually enable you to do what? Okay, so post hoc test is this. Okay. Since at least one of the cholesterol level is different, is small different from medium, is small different from large, is medium different from large. This is what post hoc test is trying to do. Okay, but we don't do that in your syllabus at the moment. Okay, so any problems so far? All right, so now what we can do is we use R. So how many of you have not tried R yet? Why, Damien, why?
I was actually planning to do it today, but
Planning to do it today.
yeah,
Your
actually,
PS2 is too tempting.
no, it's just it slipped my mind.
Okay,
Actually, no, I was planning to do it after the lab because I didn't know we were going to use it today.
okay,
So,
all right. So anyway, but have you installed it already?
yeah.
Okay, good. So let's open up your R Studio. I told you to install R and R Studio, right? So please install your R, open up your R Studio. Okay, it's a bit daunting, I'll say. So this R Studio. Okay. Now what we want to do is ANOVA is actually using a formula. Okay, AOV is actually in R already, so you can type help AOV. Okay, press enter. It will bring you to the help page, exactly how to use this function. So I leave it for you to read it, okay, if you want to. Okay. It actually explains how to actually use it and so on and so forth. Okay. Now, so what we want is all these symbol. Okay. Basically, theta is actually similar like y equals to something. Okay, it's almost like equal, but we use equal for something. We use equal for other variables already. Multiply, it means that it's a crossing over. Okay, so let's try this one-way ANOVA first. So our format is we want a response variable, basically your y, to be explained by your x variables. Okay. So here, example, Goldilocks, determine if the bowl actually affects how fast the porridge cooks. So assuming you still remember the fairy tale about Goldilocks and the 3 bears. I think 3 bears, right? Yeah. So she has 5 bowls of porridge. Okay, small bowl, medium bowl, large bowl, and see the time it requires for them to cool. Which means that your null hypothesis is the average cooling time for the small bowl equals to a medium bowl equals to a large bowl. Okay. Now, how do we enter the data into your R first? So we enter the data into this. Okay. So we have bowls and time. So let us call porridge. Okay. And we assign porridge as a data frame, data.frame. Enter. Here you have the data already. Okay, get here and kind of raise up your hands as well. Because R, you really need to follow me step by step. If you miss one step, I can't help you. Okay, even Damien, you should try now. Don't worry.
Got it.
Okay.
Sorry, I have a random question. So like
Yes.
I zoom out in the R, then I cannot zoom back in. So is there like a way to zoom back
You
in?
need to zoom out in the R.
No,
How
like
to?
fonts were too big, then I zoom out. Then now it become very, very small, but I cannot zoom back in.
Okay. Let's see. You go to global options, tools, global options.
Okay. Oh my. Yes.
Okay. Go to appearance
Okay.
and then change the zoom.
Oh, okay. Thank you.
Or you can even change the font size. If you want a super big font size, then change the font size as well.
Okay, thank you. You work.
Okay. Is it too small for you? My font size 14. Okay, let me do this a little bit bigger. Okay, so now what you do is you type in the data yourself. So there are two ways of typing in the data. You can actually double click. There's no data here, but okay, so let's don't bother with this. Okay, so what you need to do is you put porridge equals to edit porridge. Essentially, after you edit, you want to put the new data frame into porridge. So, okay, so you press enter, you come up with this data editor. Okay, you can drop your hands first. Who cannot see this kind of data editor? It should not be a problem if you're using Windows, but you're using Mac, you may have a slight problem.
I cannot see.
Okay, what machine are you using?
Mac.
Mac. Okay. This is a huge issue. So if you are using Mac, then you actually have to install something else. Okay.
Okay.
Let me see. Squads. Okay. You have to go and find this program called Xquads.
Okay, then.
Okay. Okay.
I installed that also already.
You installed that already?
Yeah, but I still cannot see.
Still cannot see. Actually, I have no idea then. Because I'm using Windows, so I can't actually know what's happening in Mac.
Yeah, I tried to reinstall the thing again.
Try to reinstall it and see what happens. Okay, so what you want to do now is, okay, although the data set is presented this way, okay, but we cannot present the data set this way in itself. What we need to present is the time and the size. Okay, so you need to actually, the variable one, you change to size of the bowl. Variable 2, you change to time. All right. So size of the bowl, we actually say that we kind of code it in a way that 1 is small, 2 is medium, 3 is big. So let's take this value, all the small bowls, and then we put it in the timing. Okay. Here, it doesn't allow you to do that. You have to type it in yourself. So 60, 58, 61, 60, 59. Then the size is 1, 1, 1, 1, 1, 1. Then after that, you go to 2, 2, 2, 2, 2, and then type in the medium size, timing 50, 52, 49, 56, 44. Okay, then the big bowls, you go to 40, 39, 43, 44, 40. 3, 3, 3, 3, 3. Okay, so do this first. Okay,
Hi,
once you,
sir.
yes,
Sorry.
yes.
Can I'm Jordan here. Can you go back to your R? I accidentally closed out without saving my workspace.
Okay, yeah.
When I click view, then porridge,
Okay,
right?
you don't do anything because there's nothing. I'm showing you that there's nothing inside. What you need is actually this command. This line. Okay. Here you
thank
do
you.
not see this cursor because we are still in the data editor. So get the data editor done up first.
Okay, thank you so much.
Okay. Once you are okay, everything goes well, then you click on close this data editor. Now you have a cursor here. Okay. You can double click on, you can click on this view, right? Now you have the data here. That's a data frame. Okay. So think about a data frame as a almost an Excel spreadsheet. If you are done with it, then we'll wait for the rest of the classmates. Okay, please raise up a hand when you're done. Okay.
Sorry, please, can you please show your data again?
Okay.
In
You mean the data frame or what?
the data frame, the porridge, like
This
with
one?
keyed in. Okay, thank you.
Cher,
What?
start
Who are
editor.
you? You
Share,
tell me who are
share.
you first. Yun, yes.
Yes, my data editor are not showing. I'm using Windows.
Window are not showing.
That
This is
time
a
I
bit.
used got show, but now I don't know why it doesn't show.
Oh, okay. Do you see? Okay, try again. Try again. That means you close everything and try again.
I closed 2 times already.
It doesn't show.
Mm.
Mm, I really have no idea because I'm not beside you or your computer. I do not know what is the thing that I'm supposed to see. Um, mm,
Uninstall, then I install again.
uh, you can, but it sounds a bit. Should not be the case lah. You can try lah. You can uninstall our studio and reinstall again and see what happens. But at the moment, just follow as we go along, assuming that you've done it.
Okay.
Yeah. Okay, so all ready? Okay, put down your hands first. Xinxiang, are you alright or not?
Yeah, sorry, forgot to click the
Okay,
button.
okay. Then put down your hand, put down your hand. Okay, the next function, the next command is this. So I will just copy the whole thing and explain to you on R what does it mean. So literally, what I'm trying to do is to do a ANOVA based on the timing. Does a time average of a time matters with the porridge? So this is my explanation. The size is an explanatory variable. That means I group by size. Okay. This $sign is that I take the time from the porridge variable. Okay. After that, I put into a variable called fit. Okay, so let's press a porridge.
So I think it's because you got typo.
Which typo? Where's my
Yeah, you've been spelling porridge as porridge. So I don't think it
see.
can detect.
Alright, so my porridge. Okay, then I'll just put porridge DGE. I change it to porridge. Then do this. Yay. Basically, I assign porridge to porridge. Okay. Okay, so now I have a fit. Although my porridge is okay, let me just throw away this. Don't bother lah. Okay, so what you need to do is just run this line, and that's the ANOVA done. Okay, so once you're, if no problem, then you can raise up your hands as well before we see what the results is.
I'm Charles here.
Mhm.
How come, like, you know, the at the left hand side the symbol is the greater than, right? But then my one become plus.
That means you have not completed the
Yeah, I never
statement.
close the bracket.
Yeah lah, then close the
How,
bracket lah.
or just close the bracket then can.
Yeah lah. Close the
Okay.
bracket and press enter. Basically, it's asking for something else. Okay, you can put down your hands now. So the next step to get the results out from this variable called fit is to do a summary of fit. Okay, and this is your ANOVA results. Okay, the size, because there are 3 sizes, so your degrees of freedom is 1. Okay, and then your statistic as well. Okay, so this is your F, this is your p-value. This is the F statistic.
Hi, sorry, Jordan here. When I keep doing the fit, right, I've been doing it 3 times. They keep saying error in model.frame.default.
Error in what?
Model frame default.
Model. Okay, can you show your screen? I have no idea what is happening.
All right, sure.
Okay. Sorry, let me unshare my screen first.
Okay.
Okay, yep. Okay, share your screen. Okay, Jordan. Okay. Let me see if I can find something. Formula porridge time. Formula porridge. Okay, can you go to porridge, open up and see what's inside? Yeah, see, you use capital and then your function you use small letter.
Capital.
The time and size is capital but your command is small. Okay, so sort that out. Doesn't matter. Just close it. So go up. Okay, click on it.
Which one? Sorry.
Okay, click. As you click, you click. Okay. go up your cursor.
I don't understand. I'm so sorry.
Press up button.
Oh, up. Okay, okay.
Press another up button. Then press another up, correct. Now you change your time. The time, capital T. The size, capital S.
Oh, okay.
Yeah.
Thank you.
Okay. I share your screen first. Yes. Who is that?
Umaira here.
Yes.
For the how do I change the variable 1 and 2 to become time and size?
What do you mean change a variable 1 and 2 become time and size?
Cause my one it like I write the data right, then the on top
Okay.
right
Why not you show me your screen?
I can.
Yeah.
Okay, wait, Okay, see. Like
Oh, take a while.
okay, sorry.
Okay, variable 1, variable 2. Okay, try to click on the blue color cursor, the blue color arrow. Yeah, click on it. Does it should do anything?
It just reverse the order.
Okay. Right click. Because Mac, I have no idea. Okay, right click, open, inspect. Okay, doesn't matter. Then you use variable 1 and variable 2 instead of size and time. No?
Okay, can.
Yeah.
Thank you.
Alright, so let me get back.
Sorry, I'm Jolene. I also have the same problem as Jordan, but then I don't think it's cause of my typo or anything.
Okay, so why not you share your screen?
Okay, I'll show the.
Okay, let's just get.
Yeah.
Okay. Cannot find the function view. Okay, time, porridge, size, fit, ANOVA. Okay, can you press a few enter because I can't see the function, what you type.
Is it?
No, because your whatever you type is blacked out by my cursor bar. I can't see.
Like that?
No, you press enter 2 more times.
Oh.
Yeah, okay, can really. Now type for time. Okay, so can you go to porridge? You see your porridge.
So view?
Yeah, porridge. No. Your rich, not the wrong one. PORRIDGE. Yeah. Error in view. That's a bit strange. Do not find function view.
Wait.
Okay. Doesn't matter. You on the global environment. You click on the porridge. Double click on it. Click on it and see what happens.
It's not. Wait, I double click already.
Okay. Look the blue color cursor, the blue color arrow beside it. What does it show? Yeah. Click on it.
Nothing's happening.
That's strange. View. How about you edit? Okay. You see, when you edit the porridge, after you put in the porridge, it disappears. It never assign it to porridge. Okay. Edit porridge. Okay. Is this the correct one, right? So I have no idea what is happening. Okay, you close this first. Close this. Okay. So what you do is you put porridge equals edit porridge.
Oh.
Equals edit. Basically the command. Yeah, and press enter. Okay.
Hi, Cher. I think it's because she never changed her variable 1 and variable 2.
Oh.
Yeah. Correct. You never change variable 1 to variable 2.
Oh my god. Okay.
Yes.
Okay, thank you. I think that would do.
Yeah, change it and see what happens. Okay, then yeah, share your screen first.
Wait. Wait.
Wow.
I cannot. Why the arrow disappear?
Oh my goodness. Okay, how I know? That means the data screen is not closed yet. The data
Oh,
editor is not closed yet. Go and find your data editor.
okay.
See, it's not closed yet.
What's the first variable again? I'm so sorry, I forgot.
Bold, or size. Then the
Okay,
second variable is time.
then close here.
Yeah. Then you go. Now you have it already. Oh?
Let me try.
Yay.
Okay, sorry.
Okay. Then summary. Okay, so basically this is how you do ANOVA in R. Okay. Okay, but here you have degrees of freedom 2, so something is wrong. Let's go back and check. Maybe we want to do our porridge. Edit. So let's try size. We 1, 2, 3. Okay, so we have small, small. Okay, you change the variable type to character, for size to character. Okay, and change the size to small, medium, and large. Okay, see if that works better. Okay, yep. Just now. Okay, can you follow just now? Okay, so
Charles, yeah, I changed to small, medium, large, right? But my degree of freedom is still 1.
degrees of freedom still 1.
Yeah.
Wonder what happened. Small. Seems like it doesn't really. Do you change the character?
Yeah.
Okay. Try again. Because the degrees of freedom should be 2, not 1. 1 means there's only 2 samples. Yeah. So after I change it, I managed to get my degrees of freedom to be 2.
Still 1.
Still 1.
Yeah.
Hi,
I ever
mine
changed
also
it.
still 1.
Still 1. Okay. There's a way to bypass it, but I try not to show you now. Let me see. Sizes. No, not this. Okay. So who managed to get degrees of freedom to be 2? It means you get those that degrees of freedom equals to 2. Okay. Yeah.
Dr. Ling, I'm Janine. My degrees of freedom is 3.
It's 3.
Yeah.
Okay. Okay. What you need to do is for degrees of freedom 3, right? That means usually what happens is this. Some of it, after you type, you put a space. You actually recognize the different degrees of freedom already, a different sample.
Oh, okay.
For degrees of freedom 1, I have no idea what is happening. Never mind, we just leave it as it is first. That is why very often, one of the reasons why I try not to enter the data directly, because it can mess it up, okay, and come out with different degrees of freedom. So usually what we tend to do is we prepare the data in Excel. We prepare data in Excel beforehand. Okay. So for example, I can prepare this data into a CSV file, into Excel file first, before I actually do analysis. Okay. But don't worry about it. We'll keep coming back to using the same thing over a few times.
Sorry, I'm Jolene.
Yes.
I don't know what happened, but like this happened.
What do you, your presentation ended, this happened, aborted, fatal error. Okay, restart the thing again.
Okay, so is it I do something wrong or like it's just a
I don't know,
software?
it's just panic and then it died on you.
Okay, thank you.
Hi, Jordan here.
Yeah.
I tried doing the like changing it, right? The changing from 1, 2, 3 to small, medium, large. But then if I click on my data for porridge, right, it doesn't change. My size is still 1, 2, 3, even though I change it using edit
Okay, do you
porridge.
use this? Do you use the command porridge equals edit porridge, or you just use edit porridge?
I just use edit porridge.
Cannot, because you edit porridge once. After you edit, the new variable, the new data is gone, disappear. So you assign the edited porridge into the original porridge.
Oh, okay. Let me try.
Yeah.
Wait,
So
sure,
the
but
porridge equals edit porridge.
I got do the porridge, edit porridge. But mine
Still
still
cannot.
one. Yeah.
Okay. Seriously, I have no idea what happened.
Teacher, I tried to change the numbers to the small, medium, large, but when I type the S and enter click, it says NA.
Okay. It says NA because of this. Hold on. Okay, let me show my screen. Okay. Now it says NA because you never change the size. Okay, go to the size, right? You never change the size into a character. It's still very numeric. So numeric as small, medium, and large is not numeric. Yeah.
Okay, thank you.
Mhm. Okay. So later we have time, we try something else, but leave this aside first. For those the degrees of freedom is wrong, leave this aside first. Okay. If your degrees of freedom is wrong, but your sum of square error is still correct, your sum of square error is still correct, which means that you have to just divide by yourself lah. Of course, the p-value will be wrong.
Oh, sure. I got degree of freedom too.
Okay, how?
I have no idea actually.
Same, I also got.
Oh yeah,
I
mine
did
I
the
changed
porridge,
to
edit
already.
porridge.
Okay, who is talking now? Lucas or
Um,
Jordan? Lucas or Jordan?
Both? Okay, Jordan.
Okay, Jordan talk. Jordan talk.
I managed to got 2.
How?
I did what you asked, the edit porridge.
Okay,
Porridge
edit
equal
porridge.
edit porridge.
Okay, good.
But the residue I got 12 only.
The residue you got 12 only.
Yeah.
Check is the number correct? That means you have all 15.
Yep.
Aiyo, this stupid thing is killing me. Okay, doesn't matter. Leave it aside first. Okay. Any other problems at the moment? So we continue.
Sorry, this is Shin. So my degree of freedom is 1, so do I just leave it first?
Leave it first. Leave it first.
Okay.
We have time later, then we come to that again. Okay. So the next thing I'm going to show you is actually just to follow what we have here. Okay, how do you do the graphs? Why not you try out yourself? Okay, here you have to install a package first, okay, called gplots. So when you install gplots, a lot of things will ask you for installation. Yep, you start to install a few other stuff. Okay, so once it's done, you see that. Okay, you try the next few commands yourself. Okay. And what I'm trying to do is to plot the means. In this case, I'm using this library called a gplots library. After I install, I use this library function to bring it up into the environment. Then what I do is, so this is exactly what happened. Okay. So now I plot the average, the means of the porridge of the time. That means plot the time based on the sizes of the porridge. Okay, so you see this diagram here is from large, medium, and small. The x-axis label is size, y-axis label is time, and then this is the main is my title. So see whether can you get this diagram. Okay, if you get this diagram, then you raise your hand. Here is the error bar, so it actually tells you that there is a difference between the large, medium, and small. So a small bowl cools slower compared to a large bowl. Okay. Okay. The next command here is I can change the sizes as small, medium, or large. Okay, so I change the size to small, medium, or large so that I can plot instead of L, M, and S. Okay, so let's change small, medium, and large. And I replot it again. Non-numeric variable n minus 1. Small, medium, or large. Okay, this is originally because we already changed to small, medium, or large already. Otherwise, you have to change the whole word. If you want, you can go to your edit the whole thing. That's just now what we did. And here you can change the small, medium, or large by yourself. Okay, so now you can actually get the small, medium, or large. Okay, this is just to plot your data if you want. Some people like to use R to plot the data. Personally, I don't quite like it. I'd rather use your Excel to plot it. It's a lot easier to manage. Okay, because if you want to learn gplots, it's actually quite tough to learn. Normally, what I use R is to generate the statistics. Okay, like generate this table. Okay, so far, so any problem? Okay. Essentially, because your repeated measures, all this is actually not part of your syllabus, so we don't bother too much about it. So let us just see something else. Okay, you go to sessions, change your working directory. Go to sessions, change your working directory. Choose a directory where you put your that means the original diabetes data. Okay, in this case, I know where I put it. Make sure you go to the correct place first. Okay, because you need this subsequently when you do your regression. Yeah, mine is in record manuals, analysis of variance data. Okay, and then I go to here, files. Besides the plot, I will have my diabetes data set. Okay, I can bring it up, import the data set.
Hi, Jordan here. I'd
Yes.
like to ask, if
Yeah.
I change my file type, right, to Excel,
Yeah.
like, can I still import it over?
Should be able to. Should be able to. Yep. So you just see whether can you import correctly. You will actually see this table. If you see a table, that means it's imported correctly. Okay. Then what you do is you click on import. Okay, data set is not found. Okay, wanna import data set. Import diabetes. Wait, okay. Yep. So
Hi,
now diabetes. Yes, what?
Ryan here from I'm actually lost at the plotting of the graphic representation part.
Okay, so the graph is actually following this part lah. Okay, so you follow the same command here. These are the three commands that you need to use if you are still on the porridge data set. You have to install gplots first and then bring the gplots library in. Then you plot the means. Try it out.
Sorry, I'm Jolene here. Like I tried installing the package, but it didn't install.
What
Like
does it
it
say?
said error, failed to lock directory.
Huh? Okay, show me your screen. I have no idea what's happening. Okay, hold on.
Oh, I want to give up.
Okay. There is no. Okay. You have to install first. You install library.
This one?
Yeah. Okay.
There is error.
Install package error. Okay, you enter because your okay. Fail to lock directory for modifying. Okay, because your Windows you are actually putting in OneDrive and OneDrive cannot lock the directory.
Oh my god.
Yeah.
Okay. So what am I supposed to do?
What are you supposed to do? Seriously, I have not much of an idea actually.
Okay, maybe.
Okay, hold on, just press one more and two more enter. Okay, try removing the. Okay, go to your C drive. Okay, you see, go to your C drive, Jolene. Okay, user, go to users. Okay, go to your name. Go to your OneDrive. No. Okay, you move your Windows folder to the side. I'm trying to read what is underneath it. Okay, go to OneDrive, not the Temasek Poly. Okay, go to Documents. Go to R.
Oh no.
Go to R. Your folder called R.
Wait. No, but okay.
Okay, yeah, go inside there. Okay, go inside there. Okay, hold on. Move this aside first. I'm trying to figure out. Okay, okay, go and find this file. Remove. Okay, this 00 log, the first one, throw it away. Yeah, throw it away. Okay, then you reinstall your. Yeah, enter.
Okay.
Okay, then you go to the library. Library gplots. Yeah. Then it should work already. Yes.
Okay. Thank you.
Hi, Ryan here. So
Yes.
when I copy and paste the command, right, then there's an error that says error in NS-1 non-numeric argument to binary operator.
Okay, let me show me your screen.
Okay. Right here.
Okay. Okay, you press a few enter because your cursor, whatever is under. Okay. One more time, a few more times. Bring it to the middle of the screen. Okay. A few more times. Okay. Stop. Plot means binary size mean in. Now I have no idea. So your porridge time Peter. Okay. So you just remove everything, just put plot means, porridge, $, time, theta. Yeah, just stop at the size.
Oh, just start the size,
Time and size. No. You are plotting the opposite way. You are plotting size and time, right?
Oh,
Yeah.
yeah.
It's really time and size. Time over size, not the other way. Otherwise, you're asking R to find out what is the average of S. There's no such thing as average of S, the mean of S.
So size and time I switch, is it?
Yes.
Okay.
Your size is spelled wrongly.
Sorry. Size.
Yeah. Okay. Then yeah. What does it show? Size is spelled wrongly.
No.
Size plot. Okay, size plot. Normally variable. Theta porridge. You go and edit your porridge and see what's inside.
Okay.
No. Make sure you have porridge first.
Porridge, edit. Porridge.
Yes.
Oh.
See, your size is missing already because just now I made a mistake. So now you have to we put in the size.
Okay, I'll try that. Then I'll get back to you. Thank you.
Can you show how to like import the diabetes again?
Okay, hold on. Okay, so okay, so importing diabetes. Do you have the diabetes in your file already?
Yeah.
Okay, so you click on it.
No, haven't bring it to this
what do you mean never bring it out?
Like Like can you just say the session then something?
Yeah. Go to session.
Yeah.
Set working directory.
Yeah.
Directory, and go and hunt for where on earth this directory is for your diabetes.
Okay.
It is in here lah. My lab 8 data set data files. I have no idea where.
They say no item also.
Yeah, it's no item because it's actually choose working directory. You're not choosing a file.
Okay.
Because you see the data file inside has only one thing. There's nothing else inside, so it's no item. So just click open, and then here it will show up.
Okay.
Okay, you get it? You got it?
Yeah, still trying.
Okay.
Okay, so after that I just press import dataset, is it?
Yes, you import dataset. Okay, but then you have to wait for a little while, wait for it to show whether it's everything correctly or not.
Okay, thanks, sure.
And quick import. Okay.
Hi,
So,
Doctor.
yes,
Hi,
yes,
Mark.
yes.
I tried to put plot means, but I haven't got any success. They just said error could not find function plot means.
Okay. Did you install? Did you do this? Did you do these two commands?
Let me try again.
Yeah. How can work?
Alright, let me try again.
Okay. Try one at a time. Make sure it's installed properly. If there's an error message, read the error message and see what it says.
Okay, it's working now. Thank you.
Henry? Okay. All right. So based on this, what we can do is, okay, because even your two-way ANOVA is really not within your syllabus. Okay. So two-way ANOVA, you can go and try two-way ANOVA yourself if you have time. Okay, because again, it's not out of your syllabus, you can just try it. But what I want you to do is, let's say your diabetes. Now you click on diabetes, there's all the data for diabetes. So this is a good data set for us to test. Do the same thing as what we did just now. Okay, is the cholesterol different for the frame? Now in this case, the function will be your ANOVA, okay, diabetes, and what you want is the average of your cholesterol. Is it different from your frame? Okay, so it's exactly the same as what we have here. It's time and size. Okay, so will be cholesterol, theta, diabetes, frame. And we have to put this into a function, a variable as well, that's called D. Okay. So this is what you need to type, and then you do the summary of your date. Okay. So this is the two things you should see.
Wait, can you repeat again?
You know, this is what you have to type, and this is what you have to type.
Oh, just now you type the AOV then diabetes.
You know?
Oh.
Yeah. Okay, so indirectly it should show you the same output as what you have here. See, the S statistics is 4.75, the p-value is 0.00914. So this is 4.75, 0.00914. Okay, so if you get the same results as what I have here, you have actually done your one-way ANOVA pretty well. Okay, and you can raise up your hands. Okay, make sure you get the same result as what I have. So this asterisk, right, is just a significance code, which is 0. What is the significance? Okay, never put p-value equals to 0. That's a seriously wrong thing. Hey, Xavier, are you all right?
Yeah.
Okay. So for those who are up to here, can raise our hand first, so I know who's still working on it. Okay, put down your hands first. So sometimes, can we actually do two-way ANOVA? Okay, although it's out of the syllabus, but I just want to show you how it is done. Since we can actually use this, is the average cholesterol different by the body frame? I can also find is the average cholesterol different by body frame and different by location. Okay, basically what, let me just do diabetes again. Because location actually makes a difference where you come from or where you live. Okay. So all I need to do is to change the command. I add to based on frame location. Okay, then I call this maybe as D2. Okay, just hold on for a while. I'll show you how it looks like. So basically, these are the two lines that you have to put in. Now it's test based on location and based on frame. So what it means is, based on frame, it is still significant, but the average cholesterol, that means the average cholesterol in Buckingham and the average cholesterol in Louisa has no significant difference. Okay? So this is how you can do two-way ANOVA. If you want to do three-way or so on, you just keep adding. Any problem so far? Hello, any problem?
No.
No. Okay, so please go back and practice using this cholesterol data set. Okay. So let's look at the cholesterol data set itself. What you can actually do, okay, you can actually look for example, does the glycosylated hemoglobin makes a difference? Okay, what's the average age and so on? It is actually quite a fair bit to use. Now, Anova is very flexible, but what is more flexible will be what we're going to do next week, which is on regression. Okay, so please go and look through your R, go and practice your R until you're comfortable with typing commands. Okay, because regression will be quite interesting. Regression will be using diabetes as well as different set of data. Okay, how do you do scatter plots and so on? So this is actually quite useful for you in your work. All right. So if nothing else, really, that's about all for today. Any problems or anything that you want to find out?
Hi, Jer. Can I see what you write for D2 again?
D2 again, okay. D2, this one.
Oh, so I don't have to put like D2 equals to something else.
No, D2, this is that means it's the average cholesterol based on frame. Does it differ based on frame? And does it differ based on location?
Oh, okay. Thank you.
How about if I want to combine frame and location? Because we have 2 locations, we have 3 frames. So can I say that does average cholesterol in, let's say, large frame in Buckingham differ with the large frame in Louisa or something like that? I can do that as well. So I can actually do a D3. And instead of this plus, I put a colon. So this is what happened. So I'm breaking the location and the frame out. So now I have Buckingham large frame, Buckingham medium frame, Buckingham small frame, Louisa large frame, Louisa small frame, Louisa medium frame. So there are 6 categories, which gives me the degrees of freedom of 5. So yeah, it does tells me that the location, the location the frame versus location may actually be important. It's still significant. Okay, if you want to do this in Excel, what you end up having to do is to do here, right? If you want to do it in Excel, you have to take the location, okay, cholesterol, location, and frame. Then you have to find Buckingham small frame, Buckingham medium frame, Buckingham large frame, Louisa small frame, Louisa medium frame, Louisa large frame. So you end up with 6 columns instead of 3. Okay. So what R does is it makes your life a bit easier if you know how to use it. So far, any problems? Okay, most of the time you only need to use all these when you are doing your experiments, when you have a lot of data. Because if your degrees of freedom is too low, that means the total sample size is too low, you can't do ANOVA very well. You run out of degrees of freedom to use. Any problems? Hello, any other questions?
Uh,
Yeah, I say Charles.
Wait, can you save this thing? Or is it when you close then you open, then you must do everything back or the whole thing again?
Yes, you have to do everything again.
So you can't save.
You can save to some extent, yes, but not very useful. So you can go to session. You can save workspace, and please save a name. Otherwise, it will give you a. Okay. If you never save a name, it will give you a funny looking file that looks like this. I'm gonna save. Okay. Sessions. Save workspace. Okay. Let's say we call this as your lab 8. Okay. Then it will save as a set of data. Okay. So let me just go and show you how it looks like. If I go to R again, R Studio, I run another R Studio. Okay. Then I go to my working directory, change it. GB working materials, course, biological data analysis, lab menus, Anova data. Okay. Yes, so now I have my R data here. I can open it and import into my environment. So then I have all the data so far, but it doesn't give you the repeated work. So I can still do my summary of my, let's say, D2. It should still work. Okay, that is as far as you can do with saving, Charles.
Oh, okay.
Okay. That means what you're trying to do is you're just taking a snapshot of what is inside the environment now and kind of freeze it down. It's a very rudimentary way of doing things, but it seems to be the best way of doing things actually. Okay. So let's say when you close R, right, it will automatically ask you, do you want to save or not? If you save, if you click on this save, right, and it will give you a funny looking file. It will give you this file instead. There is actually no name attached to it. You have to go and rename it yourself. Then this R history, let's say, can I open it up? I can try, because I never opened this R history up myself. Open with yep, they actually give you all the commands you have typed so far in this session. Okay. All right. So any questions? Any other questions? You can learn a lot about things about R. In fact, it's very useful. Have you learned inside your other bio modules this thing called heat map? Heat map, HEATMAP. Hello. Yes, no. Need some answer.
No.
No, all right. Okay. Now, Excel also can do a lot of interesting things. Since we have a little bit of time, I might as well show you some of the crazy things I've done with Excel. How many of you like to use Excel to plot graphs? Anyone use Excel to plot a lot of graphs? In your report, do you use Excel to plot graphs?
Yes.
Yes, okay. So what kind of graphs you can plot? Let me show you. Okay. Course materials. Do I have it here? Workshop. Okay. Let me show you some of the graphs that I plot so far. Okay. Okay, you can plot graphs that looks like this. It's done using Excel. Just a little bit of trickery using Excel. This also plot using Excel. It's doable. Okay, and then but this you have to think about how to do it lah. It's not. It's feasible. This in itself, this is not Excel graph but an Excel spreadsheet. Okay, it's actually doable as well. So, anyone actually knows how I do something like that? In Excel, there's this function that you never actually try out. It's called conditional formatting. You can actually format based on different colors. Okay, so for example, if I have a random number, let's say a set of values. Okay. Then I can use conditional formatting based on the type of colors that I want. So it shows me how is the distribution of the patterns looks like. I'm actually looking just at patterns. So this can be very useful to show out a lot of different things. And what I did for just now that I actually just reduce this. The numbers are still inside. The numbers, every other number is still inside, but then it's reduced to so tiny that you can't probably read it. Okay. I can even reduce it a bit more based on some of the, find the smallest typeset I can use. So basically, you can't even see the numbers. Although you click on every cell, it's a number. Then what I did is kind of reduce this into a squarish thing. There you have it. Okay. Then I just copy and paste the whole thing as an image. All right, that's all for today. So see you next week and have fun.
Dr. Ling, I have a question.
Yes, it's Jermaine.
Yeah, for the upcoming VDA test, right?
Yes.
Can we use Excel and is it open book?
It's online test. So online test is by nature open book.
Oh, okay.
Yeah.
Thank you.
Yeah. But the next time, because of the new regulations by TP, you have to show your face. That means basically I have to sit here for half an hour staring at all your faces.
Okay, thank you.
Okay. All right. That's all for today. Any other questions?
Hi, Cha. Next week is
Yes,
Flex Week. Do we still have lesson?
Next week is Flex Week, man. Is it?
Yeah.
Well, how come I keep... Okay. Where am I? Data analysis. Somebody really have to tell me when is Flex Week, because at home I don't feel any flex at all. So let's see. Anova, Flex Week. This week is Flex Week. Okay. So no lah. Nothing ma.
Okay, thank you.
Yeah. So yeah, regression is the next one. Yes. So have fun. Go and enjoy your Flex Week a little bit more.
Dr. Ling, sorry, but the test will be, I mean, we have to on our webcams on MS Teams, right?
Yes.
But MS Teams only can show like 9 faces at once.
Okay, so why not? Okay, let's try out. Let me unshare the screen and see. Okay, why not all of you just show your face, and because I've never seen who is who. Okay, just show your face. Just on your webcam. And we can see if Charles is actually so beardy. Anyway. Okay, so Lucas. Yep. Yes, there you are.
I have
Okay.
MSc though, sir.
It's fine. Who is talking just now?
Damien.
Damien. It's fine. I don't really care about your MSc. Yeah, you can show up to a certain number. Okay. Okay, so let's keep popping up, Because what you will see is, okay, let me just show you my screen. Okay. And this is what I see. Okay, hold on. This is what I see. So this is what I see. Okay. So there is a lag time. Okay, what is that big bird doing behind you? Okay. Now there is a lag time based on the screen. So what I need is Ryan. Okay. Why not you bob your head from left to right? Okay, so this, let me show you my screen. So can you see me now? Okay, haven't yet. I haven't off. Can you see me? That's me. Okay. So you see me, and if I bob my head left to right, over time you find that the two heads are bobbing in a different way. Right? That is the delay in the network lag. Okay? Which also means that every time when you share screen, you have to take note of the delay. Yeah. So when you do a presentation in future, don't just share screen and start presenting. Nobody is going to see it. Okay. So what I did is, this is exactly how my home is set up. Oops. I have another computer that is showing what you are seeing. So I know what is happening. Otherwise, I share screen, I cannot see what is doing what. Okay, that's all for today. Have fun. Okay.
Enjoy.
Bye-bye.
Thank you.
Bye.
Thank you.
Thank you.